Welcome back to Raw Green. Francesco and Emma here. For 20 plus years, companies have relied on emission factors and spreadsheets to calculate the carbon footprint. But what if the entire structure is wrong? Today we're speaking to someone who thinks it might be. And that one is Spencer Brennan, founder of Neutrino, a Cambridge University incubated company that has developed a method to quantify with increased precision environmental impacts across industries.
Spencer, welcome to Raw Green. So, is carbon accounting structurally flawed?
Emma, great question, and thanks for having me. Francesco, thank you as well. I think the current state of affairs is yes. In Scope 3 specifically, when we're dealing with a huge scaling problem where we have to measure thousands of products at one time, then yes, I would say so.
Are you saying that the greenhouse gas protocol approach is obsolete?
Not at all, actually, Francesco. So the problem with emissions factors, so when we're measuring emissions in industry, what we do is we multiply what happens by an emissions factor. We never actually measure the emissions coming out of a smokestack, typically. Mm-hmm. Now, what that means is that when we have something very broad, like an airplane multiplied by an emissions factor, that can be very, very uncertain because we don't know how that airplane was made. There could be very different types of metals that were used, electronic components, all of that kind of thing. But when we go down to the fundamentals of we burned this much natural gas in an oven, and that's multiplied by an emissions factor, that's very accurate. Mm-hmm. So it just depends on the scale at which we group these things that we multiply by these emissions factors. Now, the problem with this is that emissions factors over time, we've collected these databases over the last 20 years, as you said, Francesco. And oftentimes those are outdated or they don't represent how things are actually made. So the new airplanes today are not the same as the ones from 20 years ago. So it's very, very different to understand both the emissions with precision, but also how to change those things to decarbonize them. So I think not only is there a lot of imprecision with using these emissions factors, as you were saying, from spreadsheets, but also you can't use them to decarbonize. And that's really the critical point because we only measure things in order to be able to decarbonize them.
Well, so basically we are, what you're saying, it is, we are okay with emission factors from, let's say, the raw material part of it. But when we talk about more complex inventories, such as the one of an airplane, which is 100,000 parts, then you cannot rely on that emission factors because that inventory inside hasn't been updated for, 5, 10, 20 years. Did I summarize?
Yeah. Exactly, but even more so than that. So if I use an emissions factor for steel, say I'm General Motors, I'm trying to buy in low carbon steel for my car lines, my frames, because CBAM is coming into effect and there's going to be carbon taxes alongside of steel purchase. Now, steel can be made from two different ways. It can be made primary steel from extracting iron ore from the ground, but it can also be made from scrap steel. And making it from scrap steel is much less emissive. So there is a big difference. That can be 1.5 to 3 kilograms of CO2. So there's a doubling of effect sometimes, roughly. And so actually we even want to go one step further. We want to go down to the point where we're just looking at how much fuel was burned, how many fugitive emissions were released. What are the process emissions? So is there any chemical transformations that happen when, for example, you make cement from a chemical reaction perspective? So once we're down at that level, we're okay. Once we start moving beyond that level, so even to a material list like steel or aluminum, and then of course, even worse, a very complex product like Sony's PlayStation 5, then the uncertainties and the imperfections of a measurement will compound up the value chain.
Yes. Well, in traditional LCA, we often report numbers down to the 2 decimal or 4 decimal places, okay? The problem is what you're saying is that is the current system pretending precision, Do you think that the industry, it is presenting a level of precision that simply doesn't exist? And I'm all in for this, by the way, because that's the purpose of LCA, of life cycle assessment, to go inside the precision.
1,000%. So LCA is fantastic for going in deep, and like a full LCA and doing and mapping all of the components of a value chain. Now, what's been happening recently, and this is a kind of a publication that we're going to be releasing soon, myself and some of the academics from the University of Cambridge and beyond, is that actually LCAs are kind of being co-opted to have more streamlined versions or other versions that are being called LCAs that are not actually measuring these fundamental factors times what's happening, but they're starting to use averages. And as soon as we start getting into this space of using these average emissions factors, we lose precision. And precision, you can think of it as the multiplication of what's happening. So we're making an airplane or making a kilogram of steel by the emissions factor. How representative, how similar are they? How good is that emissions factor for that kilogram of steel? And so I think, Francesco, to your question, well, there's a bit of difference between precision and accuracy. But when we think about real measurements, I'm focused on helping, for example, Sony understand thousands of components in their PlayStation 5. And we can't have an LCA on each one of those 1,000 components. Now we can do an LCA on the whole PlayStation 5, but then how do we then scale that to all the other products in their category list? And so I would say we have to balance the speed and the precision. And the way we do that is with scientific uncertainty. So you say we go down to these multiple decimal points. Professor Cullen and I always say it's great to have 4 significant digits, but actually there might be 50% uncertainty on that number. So those 4 significant digits don't mean that much realistically.
No, if you have the level of uncertainty.
There's so much to get your head around with all these different understandings of materials and processes and energy. What's your background? How did you get into this?
Yeah, well, actually, I'm a chemical engineer and environmental engineer by training. I was researching all different aspects of kind of environmental remediation engineering, stopping oil spills and cleaning up kind of heavy metals throughout water systems in the environment. And so I was very well trained in this kind of idea of, process modeling or these black boxes of material and energy in and out. Then I was thinking, crap, I don't want to follow and clean up environmental problems. I want to get ahead of it. So I came here to Cambridge to do my PhD in renewable energy technology. So I was actually creating new sources of renewable energy from waste heat, local renewable energy generation. And I was building hardware and software systems. So I was building what we call ultra high resolution measurement systems. So down to 3 billionths of a volt. So measuring very, very, very specific things.
Wow.
That's like the energy you could get out of a potato.
Exactly. And then I was just thinking, well, my research is fantastic and it can have an opportunity to create low carbon data centers, and also new renewable energy sources. But is it going to have an impact before 2030? What can we do to have the biggest impact? And so I started thinking and I started focusing in on the problem of scope 3 and actually just rolling out these reductions in material and energy inefficiencies, getting a 40% before 2030. How can we do that as quickly as possible? How can we give this information to manufacturers all across the world to move quicker to best practice? And so I garnered some support from some serious climate scientists here in Cambridge and beyond to kind of work on this reverse engineering the problem. Let's work backwards from decarbonization. Just trying to find a way to have the most impact the fastest, really.
You gotta send me material about your research, like yesterday, please. I need to learn more.
Okay, let's go. I mean, it's deep in. I'll show you. I'll show you all the research.
Please.
I want to get into the detail, particularly of that PlayStation 5 example, Spencer. I think that'll be interesting. But just at the top level for a minute, do we think that these numbers are being underestimated or overestimated when it comes to carbon emissions and the reactions, first of all?
Hard, yeah, great question. Hard to say. So I guess we'll separate two things out. So kind of the LCA approach and then the actual fundamental kind of emissions factors. So because people are now applying these emissions factors to an entire inventory, so everything that they buy in. And what we're seeing is that when they do that on a spend-based approach, which means they multiply instead of a mass-based approach. So instead of saying we buy in 10 tons of steel, they say we buy in $100,000 of steel. Okay, now there's tons of even more uncertainty, but it's also overestimation because those spend-based factors are typically made from trade data, from input-output tables, which group and over-aggregate emissions from an entire trade sector down to a product. And that's actually not how an LCA measures things. It measures from the bottom up. So we're seeing a lot of overestimation, sometimes hundreds of percents in scope 3, especially when people are using spend-based emissions factors. So that's very, very common.
Yeah.
So we're very aware of the complexity of supply chains and the transparency, or at least lack of transparency. There's actually a strong argument to suggest you don't actually want transparency in supply chains as well for various competitive reasons and things too. What are the main motivations that companies have to get these numbers right?
Yeah, that's a great question. Well, there's regulatory legislation that is really driving towards getting these numbers correct, of course. But I would say on just a competitive business perspective, companies want to get it right because they want to act on the data. So when we're only here for reporting, I'm not sure people really care that much about the precision or accuracy. Let's be honest, right? But when we need to start looking at competitive advantages, for example, BMW saying, how am I going to procure lower carbon steel? Because CBAM is going to come in and start taxing. And in the supply chain, those steel manufacturers have to prove that they're lower than the average steel production or the steel production methodology that the EU has set out as legislation. So they have to show they're lower. And when they do that and they can prove it with precision, then their steel is now taxed less. So there's direct economic impact now, starting in 2026, where precision matters, sustainable procurement, decision-making matters. If you want to actually invest in anything in decarbonization, how can you procure one product over another when there's 100% uncertainty? How can you invest in a part of your supply chain or in your own operations when you don't know really which solution or which material swap or energy swap is going to be the most effective? No decision maker on the C-suite level will ever take a decision with these kind of levels of inaccuracy.
Let me jump in on this too, because there is also the costing part. Once you get into that level of detail, you're also able to find hotspots that might be able to generate savings. You have the design part of it. If we stick with BMW, it might be convenient, for example, to factor in the use of different materials. So rather than aluminum, you can use composites like carbon fiber, which they have an initial environmental impact that is higher than aluminum. Yeah. But then during the use phase of the BMW, maybe you save on emissions from consumption of gas or any other form because of the reduced weight. So then you can play around with that once you have that level of detail that right now you don't have with that general inventory from the airplane or similar.
That's right. That's exactly right, Francesco. What we think and what I think is fundamentally already proven is that excess emissions are a signal of inefficiency in the supply chain. And we know that 40% of industry can reduce their emissions by being smarter by using materials and energy and increasing circularity. So what we call resource efficiency, material efficiency and energy efficiency can reduce 40% of industrial emissions. That's incredible. So, and it's the cheapest abatement lever. Sometimes it's cost saving. A lot of times it's even better for the products. So it's not just about reducing taxes. It's about making your supply chains and your own operations more efficient. And the only way you can do that is to what you just said, Francesco, which is understanding not only where the hotspots are, but where you can decarbonize parts of the value chain and increase efficiency for companies. Because then you can tie decarbonization to business value. Then it makes sense.
Does this, let's say, approach, which it should be, let's say, a logical upgrade of what it is the current way of doing things? For example, the EPD industry. The EPD industry, it is the
What's the
answer.
EPD?
EPD, it is the Environmental Product Declaration, and it is a standardized system to quantify environmental impacts across product categories. Okay. So you have cement, you have some regulation that tells you how you calculate cement impacts. So every cement producer prepared their APDs, the Environmental Product Declaration, and whoever wants to buy a product as a metric to compare the different environmental impacts across the different cement producers. Okay, but if these EPDs are done in a way, they're all done based on a life cycle assessment, but multiplying inventories per emission factors. What Neutrino, what Spencer, it is saying, it is, let's go one level further. Okay, let's dig more into it, which is what is a normal, let's say, LCA should do. Okay, rather than a standardized version. So is your method, let's say, if you push over with your approach, okay, and you're able to standardize also your approach, because let's be honest, Spencer, if you don't have standardization, you don't have that acceptance from the markets too. If you don't have the cost effectiveness in your analysis, we don't have, I put also ourselves into the group, you don't have that acceptance from the market. So does your level of details, your level of study, accuracy, going to kill the EPD industry?
It's a great question. The EPD industry, as you said, based on LCA, we worked alongside the construction and built environment industry, specifically with these EPDs, Francesco. And, what we're seeing is that it's very, very challenging to make procurement decisions from the big home builders, for example, in the UK, based on these EPDs. Everyone's afraid to make a decision because simply we don't know the quality of the data. We don't know the boundaries of the kind of the measurements, if they're comparable. So what we've been doing and working really hard to do is be very rigorous with, this is exactly what's analyzed in this set of this chain of the way the steel or the cement was made. And we use that to effectively support and scale these measurements quicker. So for example, a lot of times, just as an example here, and also in many other industries, specifically like in data centers, when every single data center is different. You have one EPD or one LCA, and you give that to your customers, but then that's not representative of the data center that me as a customer is buying, because we took all this time to make this one EPD or LCA, but that's not what I'm buying. So it's not that effective. So what we're trying to do, Francesco, to your point, is really rapidly increase the speed of those measurements. We've built this network of 40,000 processes. And a process is kind of this unit process. It's actually fundamentally rooted in an LCA methodology. So it actually links back to the standards in a really nice way. Okay. But what a process is effectively it looks at, say we're baking a cake. We have flour, sugar, butter, and chocolate coming in. We have this oven, kind of a furnace. We have some fuel going in. Maybe that's electricity, maybe that's fuel. We have a cake coming out, and we have some emissions coming out. So we have 40,000 of those across industry. That covers roughly 80% of global industrial emissions. And with that, we're very quickly able to construct how that cement was made or how that data center was made. And we're able to make them bespoke to the real cement or the real data center. And that's really critical because the speed allows us to not only start measuring reductions, because then we can say, this is where we started in 6 months or a year, this is where we are now, we can see the real reductions. But it can allow us to do things like analyze different scenarios, like you were saying earlier. What happens if we change out this recycling method to mechanical versus chemical recycling in plastics? How does that affect packaging emissions. So it allows us to start moving in this direction where EPDs don't allow us to move in. So I think it's rooted in LCA and deep kind of fundamental production analysis, but it allows us to then be precise and fast to tackle the problem.
Well, you cut the time on the complexity of modeling the various 40,000 inventories that you developed, basically.
Exactly. So what we do is we prioritize how things are measured, and that's the really critical part. Because when you're measuring something, you're trying to get to very high accuracy. But when you're doing really long LCA, full LCA, that can take 9 months to a year.
Yeah.
What happens if we can do it in a few weeks with the same precision? Maybe even more accurate, because we can understand what the uncertainties of using those emissions factors in the LCA are. And so when we can make it 10, 20 times faster and cheaper, we can now start scaling this across different companies.
But one of the biggest, let's say, time constraint that you find, doesn't matter if it is LCA in anything regarding sustainability reporting, it is to gather the data and information from the supplier of your clients. That is the very first bottleneck, without even talking about the quality of the data that you're able to gather from your suppliers. Okay.
Yeah.
It is just because in the vast majority of the cases, they don't even have the data that you need to prepare that modeling. So one way or another, you have to use a proxy to develop your inventory. My question is, provided that you're able to scale up and you optimize also on the data from your supplier, what would an auditor say if they look at your modeling, at your system? If I am a third-party verifier under, let's say, ISO 14067, okay, on the product carbon footprint, and you present your model, can I audit everything, like even the assumptions?
Yes. That's the wonderful thing about our model. AI, we haven't spoken a lot about AI, but AI really falls over
Nobody does.
in this place. So AI is a very broad term, but I'm talking about using LLMs to infer what's happening to make a product and then assign some uncertainty. There's lots of hallucinations. There's no audit trail. When we are tracking the production processes and making the assumptions that we do, it's always tracked. So we can see the chain by which we've created the steel. Has it gone through the chain of scrap steel and secondary, or has it gone through the production chain? It's every little unit process is tracked and auditable. So we've already been kind of reviewed by some of the major auditors and players in this space. And our mission is to make this dynamically auditable. And we kind of follow the PACT framework. So the PACT framework does two things. One, you can get your system audited and assured. Two, you kind of do limited assurance directly in auditability, directly in the measurements themselves. So now some companies have been coming to us and saying, oh my God, we're getting audited by PwC. We know our emissions factors are bad. We know what you're doing is way more rigorous. We're switching to what you're doing. Yeah. So we're seeing that in real time.
That's good. That's very good to hear, because you need that level of precision. I'm all in for the job you guys are doing. The question is, are there players in the market that feel threatened by what you are developing? For example, conventional database providers, like, I don't know, to name the most famous, EcoInvent or Gabi or any other Carbon Minds or any
Great
other.
question.
Yeah.
We've had great
Do they like you? Do they hate you? Let's be honest.
Yeah. Honestly, I think this is a very disruptive approach, and I think it's absolutely critical for decarbonizing Scope 3. And I think we have a little bit of a different approach because we think backwards from decarbonization. So when we started the company, it was a bunch of climate scientists and myself, and we started thinking about how do we work back from hitting 2030 targets, whether that be global targets or company targets. And so instead of saying we're going to kind of carbon account and do an LCA and do these product lines, we thought, how can we reduce a company's supply chain emissions as quickly as possible with the least amount of data. Now, because we have those different mindsets, we have slightly different products and offerings. So there's still people that need to do LCAs and provide an ISO certified LCA into a market for a big thing like a data center, for example, in the US. But we're often used when companies want to go in and measure circularity, when they want to look at inefficiencies in the supply chain operations, how to cut costs, how to quickly hit targets, how they can really action off of that data. And you'd think they were absolutely aligned, but actually sometimes companies need both. So I've had many discussions with EcoInvent, for example, and I know some of the team at Cambridge worked with Carbon Mines. There's always going to be kind of places for these data players in the space, I think. And we're just at a bit of a different part of the market where we're really focused on action.
So let's dive into this example that you touched on earlier, Spencer, in terms of it was PlayStation 5, wasn't it? Give us an idea of how your service can ultimately get to where we want to be, which is that 40% efficiency improvements, the resource material efficiency, and ultimately the reduction in emissions. That's what the planet needs. How are you helping us get there?
Yeah, that's a great question, Emma. So when we're looking at something very complex like the PlayStation 5 or even, an aerospace turbine blade, any kind of like manufacturing process, we need to understand how those things are made. And that's what an LCA was built to do. We just need to do it way faster. So I think Francesco and I are kindred spirits in that respect, which I really appreciate. And so, but when you measure things on a material and energy level, you can exactly know what best practice is and how companies are off of best practice. So then you can say, wait a second, if I look at, 1,000 components in the supply chain and I understand just a few points on each of them, I can start saying how far off of each one of those are best practice. And I can say what they can do to change their material efficiency, so reducing waste. I can say, why are you using so much energy in that? That's not the best practice energy. You can do it 20% better. So we can start flagging these different components where these companies can make changes very quickly and move to best practice and consistently benchmark themselves to best practice year on year. And you have a domino effect once you make that change, because then you're cascading across the supply chain, all of these different changes. And so specifically with the PlayStation 5, we're looking at all the inefficiencies. We're looking at how increasing circularity in plastics can reduce the emissions of the box. And we're helping really tie measurement to reductions in action plans. And we do that also across aerospace, for example. We have one case study right now publicly with a Japanese aerospace company, and they're selling these turbine blades to Europe, and they were cutting the blades out of this big chunk of metal. But if they close form cast it, they can save 80% of energy in pre-machining. They can reduce their material waste, so the cutting out and the recycling of that, by about 50%, because of course they've cast the blade very close to the final shape. They can save 1.6 million euros in costs, and 41% in emissions. So you start to be able to tie emissions reductions with efficiencies in a way that actually provides business value. That kind of changes the game for the supply chain.
Yeah, it does. And I can also imagine that once you've got all that data and you've measured that benchmark, in the future, as new things are developed, new chips are designed, things become more energy efficient as we go. You can start putting that back out to them, can't you? You can
exactly
almost do a recall and say, we can improve it another 20%, bring it back in.
That's exactly it.
Yes.
That's why, and because 2030 is so close, and that's fundamentally the problem with where we are right now. We have long form LCAs that, take a long time to do, maybe a year to do. Then we have these really quick and dirty emissions factors that don't give us the insights. But what we need is something that actually links the two. We need the precision of the LCA, we need the speed of the emissions factor, and we need to be able to hit best practice year on year to 2030, because we need to show those reductions. So yeah, your point is spot on, Emma.
That tells you, though, this is something that behind closed doors, Em and I have discussed multiple times. Tells you also the precision of all the sustainability reports and targets that are out there, especially from major corporations, and the value that those numbers have.
I mean, absolutely. I mean, some teams are world class. So we work with some teams that are all PhD in LCA. Francesco, probably the same knowledge as you, and that are really serious.
you.
And we work with some we work with some companies that just use spend-based emissions factors, and they say, okay, Microsoft sells this much this year, and we buy 0.001% of Microsoft, so that's our emissions, which obviously has no relatability to what the real emissions are. So, so yeah, exactly right. So there is a challenge with the global emissions reports, and that's why we have seen very, very few companies globally being able to hit their science-based targets or be on track to, right?
Yeah.
We've seen reports come out that companies have to 20x their decarbonization roadmaps to hit science-based targets by 2030. And that's kind of where we stepped in to say, okay, we need to rethink this a little bit. How do we start hitting those targets very quickly with the least amount of data possible, and using precision and uncertainty to quantify every step of the way how we're improving measurements, but also how we're decarbonizing and improving efficiencies.
I was reading this book a while ago. It's called The Terraformers. I don't know if you ever heard of it. And basically, these guys, it is like 3,000 years in the future. And they developed, for lack of better wording, an incredible IoT system that calculates on the spot environmental impacts on the second there with live sensors and measurement and monitoring that factors in.
Yeah.
I mean, we should not be that far away from that.
Oh,
We
Jesus,
do
I hope we're
have-
not still talking about LCAs in 3,000 years' time, Francesco.
Spencer and I, yes, they're still going to be there talking about it.
Francesco and I, we like to get into it, don't we? Yeah. So on the real time aspect, you're right, Francesco. I mean, we're not at a place yet where we've connected IoT and factory level optimization and energy management systems with LCA. And I guess my answer would be, does it really matter right now for emissions reporting? It matters for decarbonization, because if you're trying to optimize, a furnace temperature and the grid, so because in the energy grid, of course, we know that there's a mix of different sources of electricity, and so when we go to the times where there's a lot of demand, there it might be that the grid might get a little bit dirtier, we call it, because we have to spin up a coal-fired power plant to meet the demand. So there's a lot of optimizations that we can do on that level, and I think those are very valuable, Francesco. But when we think about it, we're not even close to that problem. We're using emissions factors for 20 years ago that have no representation of how anything was made. So just to be able to go to a product, this is how the product was made this last year. I don't think yet we need the real-time aspect. I think that can help for some parts of decarbonization, but in terms of precision and in terms of understanding broadly the material and energy efficiency, we can do that on a quarter-by-quarter or year-on-year basis to start with now, to make a huge leap in precision and in actionability.
I think until carbon isn't priced the way it should be priced, that you have that sort of incentive, we will not see, IoT and live sensoring deployed. But when you start to have that kicking in, say, okay, even a 0.5% variation is going to affect my P&L at the end of the year. Let's start to put some sensors into the warehouse or in the production floor. Let's see what we can do.
I mean, I think it's really important to remember that these uncertainties are astronomical compared to financial data. And financial data, a dollar is a dollar, and we can track that. But in emissions, when you make a simple chemical like polyethylene, like ethylene, a simple precursor to polyethylene, there can be, we've measured 45 times difference in emissions.
Oh, wow.
45 times, depending on the feedstock and the process that you make it by. And so when you take a number from EcoInvent that's 1.7, and you take that as your number, but it can be 0.3 or it can be up to 14 or 15.
Oof.
There's the system has to change.
No, yeah. I agree with you 100%. 100%. There is an industry
now.
It's unbelievable. And so I think people just don't understand these variations. Like we're talking about totally different products almost. And that's why, we have to do the rigor of the LCA, but we just have to do it, 10, 100 times faster. Yeah. And we can use some parts of AI or data collection to be smart, but it can't be the fundamental layer of how we measure things, to Francesco's point, because we need the certainty, we need the auditability. We also need the efficiencies to show that we can actually change something. It's very hard to convince a manufacturer on the floor to say, oh, AI, ChatGPT generated this reduction lever or these emissions for your process. They're going to say, what? We're on the floor every day. We know this better. And they do know it better.
There is an industry that it fascinates me because I know nothing about it and because there are no information about it. That's the pharmaceutical industry. There is nothing.
We're just starting to get into pharma, and it's very interesting. I can't say too much about the actual details because it's very confidential.
Tell us everything. Don't worry about NDAs.
But it's very interesting, and they have a big problem. So actually, the NHS has a very stringent targets to reduce their emissions and get supplier data by 2027, 2028, and pharma is a big part of that. And so now we have to go in and we need to support, so I guess as climate scientists, we feel it's our mission to go in and fight in spaces that are really challenging. So in pharma, in electronics, we need to push industries to best practice that are struggling to move and that are untransparent. To your point earlier, Emma, where we need to have a database or at least impersonal or third-party body that sits in between buyers and suppliers to share data. I can't take Amazon's supply chain data and give them how all of the supply chain companies make their products. That is a competitive disadvantage for all the suppliers. Yet Amazon still needs to understand the emissions and buy lower carbon. So there has to be something that sits in between each part of the node in the chain to add value to the chain members. So we need to find a way to lower costs or increase market share for the players, but also to separate that production level data and the buyers in terms of the higher level emissions data that they need to make a decision. So that's a really important kind of security concern that we're working on.
Sitting in the middle like that puts you in a very powerful position as well, because you then have you then grant license to operate to some extent, because you could potentially omit the worst offenders, you could promote the best offenders, through giving that accurate data, you're starting to then pull the levers on actually some of those changes that the companies are asking for, they've just been unable to do. It's exciting for Nutrino.
Yeah, it's really exciting for us, and it's hugely valuable, and we're trying to just be the most transparent and honest about it as possible. We're not saying that, Francesco, we're the best in the world at calculating this one thing, but I will tell you that we're the best in the world at calculating something and giving you a true representation of the data quality from very, very rigorous scientific uncertainty. And I'm going to tell you how to reduce that data uncertainty and increase the quality year on year. And I'm also going to tell you how to do something about the actual emissions. So at the same time of, we started off this discussion about, being more precise. And I think precision or accuracy is incredibly important. And that's what we call moving towards action grade data. How do we know when we can act off the back of a number? Because right now, in scope 3 inventories, we cannot.
No.
So that is our fundamental goal, is action grade data moving towards real decision making in businesses.
So the question is, if Neutrino succeeds, what industry disappears? Sorry.
Great question. Yeah. So currently we're multi-industry, and the reason we're so varied in industry is because like I said, we've mapped 80% of the global industrial emissions on a production level, which means we know how things are made, which means we can help a company like General Motors, for example, look across all different aspects of their car because they have advanced electronics, they have glass, they have steel, aluminum, they have rubber. So we are in many industries, so it's specifically aerospace, automotive, the built environment as well, chemicals, pharma. We're in telco, and and a few more. So we're really pushing out. Another example is, I guess this is similar to built environment, but we're helping the UK build a greener energy grid. So we're actually, which is really kind of inspiring to the team, is to be able to help decarbonize the grid here, which is then, of course, passive decarbonization for everyone else. Everyone wins from that. And the way we do that is helping them understand and procure lower carbon infrastructure. So, that's cabling, that's transformers, that's all the things that are going to connect the new onshore, offshore wind to the homes and the businesses and the factories here in the UK. It's very important to be able to find ways to reduce those emissions and reduce the product level emissions of all of those components.
Well, the thing that makes me very happy hearing this stuff from you, Spencer, it is that we are finally and I can feel it besides neutrino also on other tables, we're moving away from carbon accounting as a boring accounting bookkeeping exercise towards more engineering, so carbon modeling as engineering, rather than, again, a simple plugging in numbers and multiply them for a monetary value connected emission factors. Okay, which is it is probably a waste of time and money to do something like that.
I totally agree, Francesco. I mean, we've seen this so many times with other conversations that there's this evolution now from reporting to action, from data to decisions.
Yes.
And you're going to be a crucial part of that. I think it's wonderful.
We haven't got all that time. We need to speed up. Yeah,
exactly. It's a story. To me, it's a story of hope. Like now is the time where we can use all of this engineering and these insights to actually first align business value. I mean, let's be honest. Like you said, Francesco, do we really want to just keep carbon accounting for the sake of carbon accounting and reports?
It's boring.
Like nobody is really that passionate about that. I mean, it's fun to make to make an analysis, and I'm an academic, so in my past life, so I like that just as much as everyone else. But I think it is really a story of hope that we can now take this industrial engineering knowledge that we've accumulated over the last 20 years and bring some good to bear, and hopefully some increased precision or some increased data quality or some action grade data to the world, and just be part of that whole journey. If we flip, like I said, if we flip around our idea of, moving from, everyone thinks, we can't manage what we can't measure. And that's true, but it means that measurement predates the decarbonization. Which is true, but let's just think about it the other way. Let's just think about it as, well, how are we going to decarbonize the fastest? What is the things that we need to measure the quickest? If we kind of reverse that mindset, that's kind of where we're at in terms of utilizing our skills and this kind of engineering approach, like you said.
Yeah, because also it moves from being a compliance exercise to something that can actually generate value for the company, right? Where you can optimize under so many angles. You can make better products, cheaper potentially, with less environmental impacts, rather than say, oh, I have to comply with, I don't know, the regulation of the day that this week the EU came out with or whatever. So
exactly.
It is a completely different way of running sustainability, of doing sustainability for your business.
It's competitive sustainability, Francesco, and it's even reframing sustainability in general to, instead of being, oh, I'm tired of doing these reports, or just, or it's a burden to the business, or people in the sustainability teams being seen as kind of the black sheep, not adding value, to flipping that on its head and saying, the future is going to be lower carbon. We know that. So they need to be involved in design decisions. They need to be involved in procurement, and they need to be involved in making the business more efficient. So,
Fantastic.
yeah.
That's wonderful, Spencer. And we're going to be watching the journey of Neutrino and you in the next few years, because I think it's got some big future. Thank you so much for joining us.
Thank you for being on Raw Green, Spencer. We catch up soon.
Thanks, Francesco. Cheers, guys.
Thanks for listening to this episode of Raw Green. If you made it this far, you probably enjoyed it. So don't forget to hit subscribe and follow our podcast. It's an awesome way to support our community. At Obi, we're all about research, life cycle assessment, and the green tech innovation. Stay in touch through our socials or visit our website. Links are ready for you in the description. Catch you in the next episode. Ciao!